So what we're looking at is a time lapse. So we're looking at the time span of maybe about 1 hour. But within perhaps half an hour, we get as much as 12 foot, like 4 meters of increase in the height of the river. Welcome to the Geo Show. So today we are going to discuss the very, very tragic events of the Texas Hill Country flash floods that occurred about 2 weeks ago. Now, this was a very, very dramatic, tragic disaster where an estimated 170 people have lost their lives, many of whom were young people. So there were many children, teenagers camped on the banks of the Guadalupe River. And this has caused this huge tragedy. Now, what we're going to discuss is first the geology and then the geography, so what factors went into the disaster itself. And then get into the question that every natural hazards geologist should ask, which is, was this disaster preventable? So the Texas Hill Country is part of what's called the Edwards Plateau, which is a large landscape that sits higher than the surrounding landscape. Now, classically, this type of landscape, so this incised plateau geomorphology, is caused by uplift, which means that the entire landscape gets pushed up by tectonic forces. In this case, it is slightly different. So the Edwards Plateau is considered to be essentially tectonically inactive. So it sort of stays still in the same place. And everything towards the southeast is moving down, basically under the weight of all the sediment that was deposited there by the Guadalupe River and various other rivers. And it slides off of this really large fault called the Balcones Fault. Right? So the whole landscape stays in the same place, and then everything around it is sort of moving down. And the effect is the same as it would be if there were uplift. So the whole landscape is moved higher with respect to the surrounding landscape. And the drainage, so the rain that falls on this plateau, it will weather all these rocks and it will erode all this material, forming over time this pattern of gullies and trenches and various features that relate to all this erosion from this plateau. So in order to understand flooding, we need to understand the concept of drainage basin, or watershed as it's also referred to. So a drainage basin is the entire surface area across which all the precipitation that comes down channels into one river, right? So here you see a very beautiful image. It was constructed from satellite data, and they've automatically calculated the exact separation of all the various drainage basins. And one thing that immediately becomes obvious is that a huge portion of the United States drains into the Mississippi River, which is by far the biggest river, obviously. Now, the particular drainage system that we're looking at is part of the Guadalupe River Basin, which is here visible in light blue. Now, a drainage basin can be further separated into sub-basins. So this is an example of this. So here you have a sort of main river arm, whereby each tributary has a sort of sub-drainage basin of its own. Now, why is this relevant? This is because where we're going to be looking at in Kerr County, Texas, we're at the very distal end of the Guadalupe River. So we're really in the position where the river originates, which means that the vast majority of the whole drainage basin is not included in the whole disaster, right? Because it's downstream from where the disaster happened. So in this case, it's very helpful to look at the very basic mathematics of the different processes that are involved. So if we were to quantify the rain intensity, rain is obviously a volume, so it's a cubic inch, cubic meter per unit surface area, which is a square meter per second. That's the intensity of the rain. which dimensionally comes down to meters per second. So rain intensity is defined in terms of a velocity, in terms of a distance over time. Now, the second thing that we have to look at is the surface area of the watershed, which is, of course, dimensionally square meters. And if you were to look at the intensity of the runoff, which is what causes the flood, then we're multiplying the rain intensity with the surface area of the watershed. And that gives us something in the dimension of cubic meters per second, right? So the volume of water that moves through these rivers is simply the product of the rain intensity in meters per second and the surface area of the watershed. So roughly, the volume that is going to move through the river is these two different parameters multiplied by each other. Obviously, the world is a little bit more complicated than that. So, for example, we have infiltration, right? Some of the water that comes down with the rain will not end up in the main river, but will simply flow away through the rocks and the soil. And also, some of it's going to be lost to evaporation. Now, in the case of our flood that we're going to look at, the landscape is such that there's the bedrock is very close to the surface, and it contains these very thin layers of clay. So the amount of infiltration in this area is notoriously low. Also, the rain event occurred at night, so the amount of evaporation is also extremely low. So basically what that means is that the circumstances were ideal to maximize the amount of rain that comes down and funnel that into the stream of the Guadalupe River. So now that we've discussed about the drainage basin, let's look at what event caused this influx of rain. So they have satellite images that show you the development of these storms, and you can actually see when exactly these storms took place. So around the 4th of July, there was a very unusual weather system that for some reason, one way or another, got stuck in the same place. So a lot of these storms are very dynamic. They're always moving across the entire map. And what you see here at this moment in time, you can see that this storm system that sticks around in the same location. And that is really a crucial event, a crucial factor in this whole story, because the fact that this system stuck around above Kerr County for so long meant that an enormous amount of rain was dumped on this location in a very short period of time. So about 4 months worth of rain was deposited on this watershed, on this drainage basin, in a single day. And obviously that all funneled into these various canyons and various tributaries and caused an enormous pulse in the discharge of these rivers. So this particular weather system is referred to in all the articles as a mesoscale convective vortex. Now obviously this is a bit of a very complicated meteorological term, but mesoscale simply refers to the fact that it's medium in size. So it's not as small as these isolated thunderstorms that just show up and then disappear, but it's not the size of a full tropical cyclone. It is an exponent of a larger tropical cyclone that passed over Mexico, and it formed a sort of system that spewed off various smaller thunderstorms onto the continental United States, and these coalesced into this mesoscale system, which then, as I explained earlier, got stuck and sat around above this area in Kerr County for an extended amount of time. So this white outline shows you the border of Kerr County in Texas. And Kerr County is where two smaller tributaries of the Guadalupe River, the South Fork of the Guadalupe River and the North Fork of the Guadalupe, coalesce. So they come together near the town of Hunt, Texas, and they form the main flow of the Guadalupe around there. Now, this area, because of this plateau geomorphology, has a very, very high drainage density. So it has a lot of these tiny little tributaries that all coalesce very quickly because there's very little infiltration into these main channels. And if you have this huge amount of precipitation that comes down because of this stagnant storm system, all of that dramatically increases the discharge of these channels. So you get a huge spike in the amount of cubic meters, the volume of water per second that moves through these channels. And because they are in size, they don't really have anywhere to go. What will happen is the water level around the channels will go up very quickly. And that's really the anatomy of a flash flood. And this area is not new to flash flood. So in fact, because of all these geomorphological factors, most of which are constant, right? This area is actually known as Flash Flood Alley. So this part of Texas, this area of this plateau, is already known to have a disproportionate amount of these flash flood events. Now, to illustrate exactly the rapid influx, the rapid pulse of surge water that came down through this area, I'm going to show you the actual data from a flood gauge. So this is located here on the North Fork of the Guadalupe River, just west of Hunt. And these are real data measured by the USGS, the United States Geological Survey, of the height of the water, or basically the amount of water that's in this river. And you can see that throughout the week in June and the end of June and the beginning of July, we've had a very constant low discharge of this North Fork of the Guadalupe. And then suddenly we have an enormous peak. So suddenly within literally minutes, or I guess half an hour or so, we get a massive surge all the way up to 25 feet. Now, one way to illustrate this better in a sort of time context is that this is on a weekly level. We can actually move this into a different domain on a yearly scale. So this is the same data as we were just looking at, but across the entire year. So here in August, or rather in the end of July 2024, we have some small storms. So they create these really sharp pulses. And but these pale in comparison to the absolute massive influx that we saw in around the 4th of July. So just this gives you some sort of size reference that these larger storms that happened last year, the biggest one that happened last year was about 5 feet, while the one that happened in 4th of July was over 20 feet. So you can imagine this is an enormous increase in the normal discharge of this river. So another factor that determines the intensity of these flash floods is one that people don't talk about very often, but is actually really important, which is the shape of the drainage basin. So you can imagine if you have a very, very elongate drainage basin, then all these tributaries are very far away from each other. So all these various small flood pulses, they will not coalesce at the same time, right? They will gradually move through the main channel. Now, in the case of this area, especially in the North Fork of the Guadalupe, we have a very high density, very compact drainage basin. So a lot of these smaller pulses, they coalesce around the same time. And that all contributes to this huge flood surge that we saw. Now, one thing that you might be thinking at this point is that, okay, so these streams are really close to the starting point of the river, which means that only a very small part of the whole drainage basin or watershed is actually involved in this. So doesn't that mean that floods should become more intense and more common further downstream? Now, in some cases, this may be true, but often rivers obviously have been dammed, right? So humans have, at this point, dammed a huge proportion of all the rivers in the world. And the Guadalupe River meets a very large dam called the Canyon Dam just outside of this fault that demarcates, that forms the edge of this plateau. Now, a dam is something that humans can control. So if there's a huge pulse of water coming, then they could decrease the amount of flow from the dam, and you could stop basically the flood from affecting people downstream, right? So because of this, a lot of floods are prevented. But because we are dealing with these small streams very high up in the system, we don't have this luxury of being able to control the pulses of water when there's a big storm. So this disaster in the Kerr County happened in the middle of the night. So it's unlikely that there will be really good footage of exactly what happened. But actually, a couple of days or weeks before this disastrous event, there was another flash flood in the Llano River, which is just due northwest of the Guadalupe River. So this area sits in the same flash flood alley. And here there's very good footage. There's a very good video illustration of how incredibly rapid the water can rise during such a flash flood event. So what we're looking at is a time lapse. So we're looking at the time span of maybe about 1 hour. But within perhaps half an hour, we get as much as 12 foot, like 4 meters of increase in the height of the river. So essentially, the flooding occurred everywhere around this whole area. So there were casualties anywhere from this area in the South Fork of the Guadalupe River. There were some casualties in Hunt, which lies at the confluence of these two forks. Some in Ingram, and some as far as Kerrville, which lies all the way next to the main arm of the Guadalupe. Some of the more tragic events that took place happened in this area, which is called Camp Mystic. And this is at the South Fork of the Guadalupe River. And there's one other arm that comes here in from the south. And basically this whole area that I highlighted in white became submerged. So within minutes, or maybe 15 to 30 minutes, the entire white area became inundated with water. Now, one thing that you can use to visualize the power and the intensity of this flood are satellite photos of the ground zero from before and after the event. So most of the casualties, or many of the casualties, occurred in this place called Camp Mystic, where unfortunately a lot of young people were camping in some sort of summer camp. And this summer camp is located right at the banks of the South Fork of the Guadalupe River. So the South Fork runs across the top of this image. And then there's a second tributary that moves in from the south. And in this before image, you can see this camp. So these blue boxes that you see are tennis courts or volleyball courts or some sort of sport facility. And if you toggle to the next image, then you can see that they've been totally destroyed, right? So this water rose very suddenly and very vigorously, and it had enough power to basically destroy these sporting facilities. Now, another thing that illustrates the speed and the force of this event is the trees. So if you go to the before image, this area just south of the South Fork has a bunch of trees sitting there that are just completely gone after the flood, right? So this is an extremely powerful and vigorous event. And the people that were camping there without any prior warning would really have had no chance to get out of there in time. So a lot of the soil you can see has also been completely removed by the energy of this flood. So it just kind of shows you the intensity, the power of this flood event. So one thing that everybody wants to know is, could this tragedy have been avoided? And in this case, I think it's a very difficult question because on the one hand, it's known that these flash floods occur here regularly. So some people talk about a recurrence interval of about 100 years, which might seem like a lot. So just to explain, a recurrence interval is the statistically estimated time across which an event is statistically expected to occur. So 100 years, you could argue, okay, so that's a very long time. So the odds of this happening is very low. But you have to realize that there are dozens of counties in this hill country in Texas and thousands of counties in the entire United States. So a 100-year interval event on the scale of the entire United States is not that rare, right? It's expected to happen probably multiple times a year, right? One way or another. Now, that being said, hindsight is always 20/20, as they say. And this particular set of circumstances with this very rare, unusual, stagnant storm cell on top of this area was just an extremely unlikely meteorological event. Now, there are about 5 or 6 storms, perhaps not of this magnitude, but summer storms here every month. So it's really difficult to close down all of these river valleys, up to 5 or 6 times a month. That's really not possible. So that concludes this episode of the Geo Show. I hope you've found this insightful and that you've learned something about flash floods and the exact geological factors that played a role in the July 2025 Hunt, Texas floods. So I hope you learned something, and I'll see you next time.